Alright, YouTube, another video for you guys today. We're talking about inverters here, right here at the JW Solar USA. On today's video, I have two sets of inverters here, and in pairs. The one on the left, the two on the left, the gray ones, they are made by MPP Solar Incorporated. These are hybrid inverter chargers and charge controller built in. That means they can serve the purpose of everything you need on an off-grid and grid-tied situation. And the other ones I have there, those are grid-tied inverters with limiter with a battery option. If you can see at the top of it over there, you can see a red and a black terminal. That being said, these inverters are all awesome inverters. The only thing is the size and different function they perform for your needs. Okay. All right. Let's talk about the MPP Solar. Those are 5 kilowatt, 48 volt inverter charger, grid tie integrated, standalone inverter, and battery-less. You don't need batteries for those. They can run on their own, just like the blue ones over there. They can run without batteries. They can run with batteries as well. But this MPP Solar, they're awesome, and they can provide all your house needs without batteries, and they can provide all your needs with batteries. They can provide all your needs with grid-tied system, and they can provide all your needs with grid-tied and battery backup. This is what I meant. You can connect this thing to your solar modules, which can give you up to about 45 kilowatts, 4,500 watts of solar on each of this. They can take approximately 9 kilowatt, almost 10,000 watts. 10,000 watts of solar and 10,000 watts of power output. Okay, they produce 5 kilowatts out and 4.5 kilowatts in solar. They run at 450 volt DC, each of them, which you can parallel them, or you can go a single configuration. They run by themselves. You just have to be creative. You just have to make each inverter for different load. For example, you can have an inverter, one of them, to be a grid tied. It can be a standalone. It can be inverter charger on one of your breaker box you're gonna design for this. But mind you guys, these are not just the standard American. It's 120 volts. Okay, these are the international version. So these are the 230 volt AC. They can take up to about 450 volt DC, high voltage, but you can only run them at 430 volt DC for you to have a breathing space for this device. So this is the other thing about them that's really cool. This inverter can surge 2 times its capacity. As I've said on my videos, and you can go back and confirm with it. So if you search 2 times its capacity, so you can search about 5 or 10,000. So 5 times to 10,000 are the split of 5 seconds. Okay, it can't stay like that. Don't connect it to think it's gonna surge all the time to 10,000. I can just buy one. No, that's not the thing. It can surge 2 times rated at 5 seconds. So these ones you can parallel the MPP Solar hybrid inverter chargers and charge controller. It has a built-in charge control in it, which is a MPPT, which stands for maximum power point tracking. So you can maximize your panels. It doesn't mean you have to have a lot of panels to get a better efficiency or to get your needs or demands. Nowadays technology, the way it has been improved, you have a minimum or medium of solar, then you use a maximum power point tracking MPPT charge controller, which this one's already embedded into, and you can able to produce more power than ever before compared to PWM. But they all have their advantages and disadvantages. So I'm not just talking about good things and bad things about them. All right. So this is the benefits of having an MPPT, because you can drive a high voltage, with a PWM can't let you drive high voltages at all. But MPPT can drive you, let you use high voltage, which this one recommend 120 volt. This one right there, there's two, 120 volts to 450 as per specification. The recommended required voltage is 120 volt, which is the rate for the threshold for the maximum power point tracking to recognize that these are the kind of power I want to use or I want to deal with, and continue giving you what you need. But you can only run them to 430 volt, so don't push it. Okay. Let's go back to the grid tied with limiter. Those blue ones can run, just one of them is a kilowatt and two of them is 2 kilowatts of machines right there, which is 2,000 watts. That's what I meant. 1,000 watts can feed into that thing. So they have different kinds of those. They have the high voltage ones. You can take all the way to 95 amps, 95 volts, sorry, excuse me, 95 volt. Okay, and these ones are only 22 volt in to 65 volt max. It caps right there. So it depends what you want to do or what kind of panels you have. But for the fact that if you want to do something like this, make sure you do assignment right or correctly, because you're going to end up with a lot of trouble when you come to sizing your solar array with the voltage issues. Because if you know the panels that you have, they're low voltage, this blue inverter, grid-tied inverter with a limiter, they can do the job. They can take your panels, like for 12 volts panels like RVs and very low voltage but the amps are high, and you can work with them. So you can series those to give you the 1,000 watt. Make sure or series parallel them. So remember, if the voltage is low, the amps are high. When the amps are high, the voltage is low. So when the amps are high, the voltage is low. When the voltage is low, the amps are high. So it's vice versa. So if you have panels that you can put up to that, for example, 250 watt solar panels. So 250 times 4, sorry, will give you that 1,000 watts. But these things can the recommended is 990 watt of solar. So you do the math. If you decide to go with three of the 320s, that's 369 is 960. I would say it's gonna be a good bet. If you wanna go with that, with the 250s, you're good with that. But remember, as per manufacturer recommendation, is 990. So 1 kilowatt was 990 recommended. So they want you to push it too hard. But you can able to do that because sometimes the panels are tested in the factory with a standard test condition, which is the STC. This is what is rated at a flash, just like an X-ray light, which is very, very, very bright, that probably you cannot even get that kind of light when you bring them outside on the sun due to certain climatic condition, due to elevation, inclination, or your azimuth, or your location, your orientation, and the way your roof is set up. If you have them on a rooftop, you have them on a pole mount, there are possibilities you can do that, and it's a loss on lines when you connect the panels all the way get into your house. Voltage drops and whatever. The panel's not going to give you exactly what it's rated for. Once you figure it out, I think you're going to be still good with the 250s. You can run them on that one. You got those panels series parallel. Remember, you have to check for your amperage as well. This one, since they are low voltage, 22 volts, the panel 22 volt, they started working. They will kick in, the blue ones, they started kicking and started working. And if you have a panels that's a 35 or 38, which are 24 volts panels, so you just have to make sure that the voltage, if you were 38 volts solar panel, that means you cannot series at all, because if you series it, you're gonna be 38 times 2 is way over the thing. Approximately 72 volts, if my math is right. It's way too much, and they cannot operate on that kind of voltage. Okay, they're not gonna recognize that there's a ray. They can turn on. There's a potential you destroying your machine as well because of it's trying to push a high voltage on it, or maybe the fuse will pop. But if it's a low climate, weather condition, like cloudy or whatever, there's a possibility that your voltage doesn't go all the way up. You can see them turn on. As soon as the weather started clearing up a little bit, they maxed out. They can't. I've seen that. Things I'm telling you is something I tried, because I just want to tell you that it's not going to work. Okay? I'm not giving you information here that I never tried. It's something I tried, that's always I talk about. If I've never tried, I'm not going to recommend that to you, because I don't have no experience or don't have any history about that. So I'm here to tell you guys exactly what is going on. But you can parallel those 4 panels, because if it's a 8 amps each, these things are designed to handle that. I think it's approximately over 30 amps or something, more than that, as per manufacturer requirement, or as per manufacturer or dealer or seller specification. If you call, they will tell you. So I've done research and things about these machines I've installed in the past. I've installed previously. I'm installing presently or currently. So these ones are projects pending right now, which needs to be executed. But you guys will stay tuned and just see where and when and how these things gonna be installed. The project is going simultaneously. It's kind of slow right now. That's what you see. The videos are not coming up faster. That's rapid. You guys know when I got the project already, you see I pop the videos like crazy. So I want you guys to keep, I don't want to keep you guys waiting, pending on something. I don't like that. But there's some issues that cause the pending, which I have to work on and get everything ready, and you guys will see the videos flying like crazy. So, being said, the blue inverter, you can able to incorporate them with batteries as well. Likewise, the MPP Solar. So you can take the power from the solar array all the way. You can run this one, two of them on the same battery. Let's say, for example, this one's rated from 22 volts to 65 volts. You can run them on a 24 volt configuration. From 22 volts, you can go 24 volts configuration. You can go 36 volts configuration, and you can go at a 48 volt configuration. Just remember, you don't have to go more than 65 volt input. Those inverters can able to serve your purpose. Like you can tie them on your split face or to L1, L2, that each inverter is gonna attach on one leg of your breaker. That means you can take this one grid tied 1000 inverter, gonna be on one side of the leg and the other one on the other side of the leg. Then it comes with another function that's really really useful. It has the limiter, is a sensor that it has to sense how much power that you are pulling on that line, on that L1 or L2. It knows, then it's gonna read exactly what is the power coming up from that line, and it's gonna try and supplement that power. For example, if there was a 2 kilowatt on one and 2 kilowatts on one, and you pull in 1500, and the sun is there, and you have the panels for it, it's gonna supplement that 1500 you pull in from the grid to zero it out. It makes sure it reach exactly the demand so that you cannot put back the power to the grid. And it's gonna monitor the other line. The clamps goes on each leg coming from outside, which is the grid, coming inside your box, and clip them there, and it monitor both of them for the 240 configuration of your house, which is 120 120. And these ones are built, has automatic detection of voltage. You can use them overseas for 230 or 220 volts configuration, or voltage AC out there. That's the new features they add. And the new features again on this, like I said, is the batteries option they have on these ones. And the other feature that is added into it again, which you can able to use a Wi-Fi, built-in Wi-Fi, like a dongle on it. You can buy it, or you decide not to buy, it's fine. Then you can use your own local app, which you can download. Check on my videos on this one, you see the app, and I downloaded it trying to configure it. But I was having some little issues with it, which the communication with it, and because the manual or the software has a lot of Chinese embedded into it, which you need a translator, which I get stuck. I can't able to get the thing to be decoded into what they meant, and the translation is poor. It's not that good, how this thing has to work. But I got it all the way from that point to another level, which I don't know if I'm gonna be using the Wi-Fi built on that thing. You have a RS-232 port on it, then you can able to go about it, which I can able to show you from here. So you can see that's the remote port right here, where you can attach the remote, which is the Wi-Fi, and you have the for the sensors right here, where you can plug this device. So that's the good thing when it comes to these machines, that they can do different things as you want. It depends your demands and the configuration you want to set up for. But I have a plan, like I always do, like everybody else. The way these things has to run or needs to be run to satisfy the needs for me or needs for the customer. And it's gonna be on the next video to show you how you can able to incorporate some of these things into different application. If you don't have an inverter, but it can serve you as a grid tied and battery backup system, the blue ones. Sometimes I think a lot of people don't even know about it. They think they can just use it during the day, but they have different ones. You got to pay attention to which one. This one's you can use the battery. On those little black screen you see there, you can able to set the parameters, what voltage they need to be cut off, what voltage they needs to be start up. If the batteries get low, then shut off. Then you can able to incorporate solar panels. Let me continue back to that statement. You can put solar panels to a charge controller, maybe an Outback or Midnight Classic or Morningstar, all these other inverters that are out there, charge controllers are out there, you know, Magnum, whatever you want to use, to charge your batteries direct from the sun to the charge controller to the batteries. While these ones, the blue ones, can able to take back the power, invert it all the way. Remember, make sure don't just go over the parameters or the settings, the high end cutoff for this device, or else it can go that high. Okay, if your battery is gonna be at a float at it's a 48 volt system, have to be at a float of maybe, for example, very close to if it's a flooded acid battery, they tend to go to equalizing mode. I'm not gonna encourage you or recommend you use that kind of setting to this, because the voltage is gonna be higher. It might probably work. It depends on the battery specification, or maybe to the battery parameters. But 65 volts, if you go 65 volts, it's not gonna work. You have to stay below 65 volts. Watch my video on that 48 volt configuration I did with my batteries I set up for. I set up those UPS batteries. I have 8 of them. So I was trying to see if I can push to 5 of them. These are 12 volt batteries. But this is the good thing about that. You can put a charge controller charge during the day. It's putting the power to the battery. These ones are inverting back to the house, and it's gonna do that all day till solar go bye-bye for the day. And anytime you fire up your devices in the house, they're gonna act as long as the grid is there. Remember, you have to plug on the grid. They have an island protection. Let nobody tell you lies or tell you that, oh, these ones they put power back to the grid is gonna kill somebody, the linesman. That's not true. All of these devices are all protected. They have a island protection inside them. They have to see the grid before they communicate, and all this thing. You study how the frequency, the hertz, which the hertz, if that and back and forth, and see if the voltage is stable. If it have any fluctuation, now they're gonna sync. Okay, they just turn them right away, they started throwing power. No, it thinks for a while. You study the grid, the voltage of it, how many watts or whatever, something, you know, the hertz, which is the frequency, and before it's gonna connect and start producing power. And if the grid go bye-bye, you know, a blackout, these things can produce. The blue ones can give power back to the house. Okay, it has to see the grid. But these guys here, the MPP Solar, can give you that thing. They don't care. Okay, you can send the power, excess power back to the grid, but the only effect or disadvantage is gonna spin your meter backwards. Unless you have other loads you don't want to put into this. Let me have a huge, maybe 5 ton or 4 ton or 3 ton pump or whatever it is. that uses more power, your excess power is going back. That one you can put into these inverters. Maybe you don't want to ruin them, or maybe it's gonna just take so much on the battery. You can supplement if you're working during the day. That device always operate during the day. You can just supplement that power, the excess power going back to cover up, so you can buy power back to the grid for that huge amount of power you're gonna be dealing with. Like people having like a meal, the farms, all that kind of stuff, like a big fan for corn and whatever. You don't want to put them onto this. You can, the excess power is supposed to go back to the meter, spin the meter backwards. Then that's the meter, the power you're going to be utilizing for the extra load, and all the other loads are covered. So you're paying extra power. You're paying for extra power for that sawmill or whatever you call it, and that takes more power. But you're supplementing back to the grid and reduce that. If you have more power coming in, you're probably going to be zero out. You're not borrowing nothing from the grid. Okay, that's the good thing about it. The blue ones, no power. No, it's not going to feed back. Okay? No, it's not going to feed back. It's not feeding back to the grid at all, because those sensors limit exactly what you study the grid, how much is coming out from each line, and that's the power is gonna supplement back. It's gonna put back there exactly, so that you cannot spin the meter backwards. Smart idea, very, very smart. I like that idea, that feature on it. But you can able to use them at night as well, taking from the batteries and feeding the house. Anytime you power any part of the house on leg 1 or leg 2, they're gonna kick in. When you draw a 240 device, they're gonna draw both inverters to kick in. But just one part of the house that is on that leg is not affecting the other inverter. But if you pull in power like lights on, microwave on the right one, the blue right one or left one, and right one is having maybe a toaster. If you balance, you just have to balance your loads. Make sure you're trying to not to put all the loads on one side, because you're gonna end up borrowing power back to the grid. Okay, you don't want that. All you need, one inverter on each leg, and C, you have to balance your leg, your device on your breaker box. Okay, if you're a DIY person, you divide the loads so they can know which one is which. Is a hot water on the one side, you have the microwave on the other side. So you can't just be, the other inverter is going to be sitting down do nothing. If your load or your breaker box is loaded with all the top machines or the power consumption machines on one leg, I'll advise you to break them. Try to balance them. That's the word. Put some on the right and put some on the left, because the inverters can able to share or give the full potential of your needs when you need power, or when you demand for power, instead of you buying from the grid. Doing so, washer on one, you have the dryer on a 240. These things can supplement for the dryer. The thing is going to be running this thing constantly if the sun is there, to supplement your power constantly. They are not big inverters, they're just 2000. So if you have a 2000 watts of solar, which I'm not recommending having 2000, but it's $990 as per the sticker recommendation, and that's what you need, and that's what you have to do. You can pull 240. Is these two inverters going to engage right away? It's going to sense it and start giving power. What the inverters cannot give, you're going to borrow from the grid, or buy from the grid, which is good. At least you are not paying a maximum amount of power coming from the grid. You supplement it. That's how you reduce your bill. So you just have to know what you do. Okay, leg 1, leg 2, you can tie each one. So these are the advantages or disadvantages on the grid-tied grid-tied inverter with limiter, and with the MPP Solar PEEP 5048 mg batteryless inverter charger hybrids. Okay, so this is gonna be our topic today. I'm rounding up this video. I hope I touch a lot of options into these things. If I don't, or I'll get back on that and get another version of this. Take care and have a wonderful day. Please subscribe, like, and share to this video, and love you guys all. Have a nice day. Bye for now.